let's see how to factor a polynomial that's of degree 3 or higher. And you want to use the rational zero theorem to do this. And that theorem basically says look at the constant term and find all of its factors. So in this case, factors of negative 2 are plus and minus 1 and plus and minus 2. And we're going to call those p's. And then look at the leading coefficient and its possible factors. Well, the only factors of 1 are plus and minus 1. So we're going to call those q. And then you take all of these p's and divide by all of these q's, and every single possibility that we get we're going to list over here. And those are going to be the possible rational zeros. So in this case we have plus and minus 1 over 1 and plus and minus 2 over 1. So we only have 4 numbers in this list. So if there are any rational zeros of this guy, there's only 4 possibilities. Okay. What we're going to do is take those 4 numbers and plug them into the original polynomial. So if I call the polynomial p, let's plug positive 1 in. And it was lambda cubed minus 3 times lambda minus 2. And what we get is 1 minus 3 minus 2, so it'd be 1 minus 5 or negative 4. All we care is that's not 0. So if we plug this guy in and it's not equal to 0, then that's not a 0. So let's go on to the next one. Try negative 1. So I'd have negative 1 cubed minus 3 times negative 1 minus 2. So we get negative 1 plus 3 would be positive 2 minus 2 is 0. Alright, so that means that negative 1 is a 0 of the polynomial, which was lambda cubed minus 3 lambda minus 2. Alright, well if that's a 0, that means that x, or in this case lambda minus that number, so lambda minus negative 1, is a factor of lambda cubed minus 3 lambda minus 2. So this will divide into that evenly, and I'm going to use synthetic division to divide this into that. So our 0 was negative 1, or basically whatever number is subtracted from lambda here. And the coefficients, we have 1 lambda cubed, there's no lambda squared, minus 3 lambdas and minus 2. And then with synthetic division, add 1 and nothing gives me 1. 1 and negative 1 multiply to give me negative 1. I write that result in the next column over, right above the horizontal line. I add this column and I get negative 1. Negative 1 times negative 1 is positive 1. Negative 3 and 1 add up to negative 2. Negative 1 times negative 2 is positive 2. Negative 2 plus 2 is 0. Okay, in synthetic division, these guys are the coefficients of the quotient, and that's the remainder. And since we expected this is a factor of that, it should have divided into this evenly, which it did because there was no remainder. So this would be negative 2 minus 1 lambda plus 1 lambda squared. So our quotient is lambda squared minus lambda minus 2. So in other words, this went into this many times, so this times this is equal to that. In other words, lambda plus 1 times this guy, lambda squared minus lambda minus 2, equals the original polynomial that we were given. Can we factor this any further? Well, it's a quadratic, so let's just see if we can factor it. If we can't factor it, we have to use a quadratic formula. Are there any factors of negative 2 that add up to negative 1? Well, that would be negative 2 and positive 1, so this guy comes along for the ride. Then we get, like we said, negative 2 and positive 1. And let's just FOIL this and check to make sure it's equal to that. Lambda squared plus lambda minus 2 lambda would be a total of negative 1 lambda minus 2. Alright, so all of this basically gives me lambda minus 2 times lambda plus 1 squared. So it's equal to that polynomial.